In this video, we'll talk about transformations of square root functions, and it's very similar to quadratics. So let's recall what we know about quadratics. If we're looking at a quadratic in vertex form, we already know that each of these three letters, m, n, and p, do something to the function. M dictates your steepness. N is your horizontal shift, and remember that's counterintuitive, it's backwards from what you would think. Positive is going to move it left, negative is going to move it right. And P is your vertical shift, and this one behaves exactly like you think it would. Positive is going to move it up, and negative is going to move it down. Okay, well, something very similar happens with radical functions, or square root functions. So, if I'm looking at a square root function, the same sort of thing is going to happen. In this case, underneath the radical, that would kind of be like an equivalent to inside the parentheses of a squaring, that's going to be your horizontal shift. The p at the end, outside of the radical, is going to be a vertical shift. And m is again going to dictate some steepness. And we'll do an example where we kind of provide some rough sketches of graphs for these functions. It's where it can be very, very useful. So let's take a look at an example. So by default, if we look at y equals square root of x, it looks something like this. Now if I'm looking at what we've got here, our m is still technically 1, so we don't have to adjust the steepness really at all. This plus 1 here is going to move it left 1 unit. Okay, and this negative 2 here is going to move it down 2 units. So that means I'm going to go left 1, down 2, and then I'm basically going to draw the exact same kind of curve, roughly. So this red curve would be representative of our graph for this new function that we have. And I think what we can do from here even is we can look at domain and range if we wanted to. If we look at possible x values, my smallest one is x equal negative 1, and then I get everything to the right. And if I'm looking at range, my smallest one is y equal negative 2, and I get everything greater than that. So this can be a useful tool to also determine domain and range. You can make a rough sketch for yourself and see what the domain and range are doing, as well as giving you an idea of what the graph should look like. So let's do another one. Let's do one that's a little more complicated. So again, we're going to be kind of comparing to our default y equals square root of x, and then we're going to go from there. So let's say square root of x looks like that. Well, I know this one's going to be steeper. That's what the 3 does. I know the negative 4 is going to move it right by 4. And I know the negative, or the positive 1 here is going to move it up 1 unit. So let's start there. We're going to go up 1 unit and right 4 units. And this is where my starting point is. Now I have to kind of make it a little steeper than my white curve. So what we're going to look like is something like this. A little more drastic, rough sketch. But this is what it's going to look like. And this is where using this shifting mentality, the vertex formula, if you will, it really helps with not only square root functions, but as we go, we'll talk about polynomial functions, we'll talk about rational functions. This kind of thought still applies.